Morning, everybody. Can you can hear me okay? Excellent. So thank you very much for having me back. I really always enjoy speaking at this event. Thank all of you for showing up in the morning on day two. I know that is not always the easiest thing to do after the revelries of day one. So good to see so many of you up and moving around. Just to introduce myself, my name is Matt Gracie. I'm in Buffalo, New York. I wear a lot of hats, but what I'm talking about today is a software platform called Security Onion. Has anyone heard of Security Onion before? Does that sound familiar? Excellent. Okay. If you're interested, I put some Security Onion stickers up here by the projectors. Feel free to grab some after the talk if you want. I also have actual Security Onions here to share. If you answer a question, you get a Security Onion. Hopefully you're sitting fairly close because I can't throw them that far. I work for a company called Security Onion Solutions. I'm a senior engineer on their professional services and support team. So at this point, I want to issue a little explanation/disclaimer. Security Onion, which is the software platform I'll be talking about, is a free and open platform. You can get it from our GitHub. You can download it, you can deploy it, you can play with it. You never have to talk to me. We don't even want your email address. It's fine. Go ahead, install it, play with it in your home lab, do your thing. Security Onion Solutions, who I work for, is a support organization. So for enterprise customers who want to have a support contract, want to consult with us on architecture, want to send their analysts for training, that's all the stuff that we do. But I don't want you to think that this is some sort of disguised sales pitch. I'm going to try to sell you a commercial product. Everything I'm talking about today, you can do for free with the ISO you get from our GitHub. Okay, securityonion.com/download. That's all you got to do. All right. What am I going to talk about today? So today we're talking about detection engineering. That is the process by which you take threat intelligence about an adversary or a threat actor or something you're concerned about in your environment and turn it into detection rules. Obviously, there's a lot of different ways to do this. What I want to talk through is how we write effective rules that will be effective for a long period of time. Obviously, you can do things like, I got SSH scanned by that IP address, I'm just going to block that IP address. Yeah, that's not going to be super effective, right? You want to have a more nuanced methodology around writing these rules. So that's what we're going to talk about today. And then how you can use Security Onion to actually implement them in your environment. I have a couple of quotes to start off here, kind of definitions about threat intelligence from different sources and looking at the process from different ends. So from CrowdStrike's side, they're saying threat intelligence refers to the collection, processing, and analysis of data to understand a threat actor's motives, targets, and attack methods. It transforms raw data into actionable insights. So this is looking at threat intelligence from the production side of things. If you're a threat intelligence analyst, what you're doing is you're taking telemetry and raw data and looking for trends and looking for insights and trying to turn it into a sort of a profile that you can use to guide defensive action and detection engineering, right? You don't just have a spreadsheet full of IP addresses. Instead, you look for trends and you try to figure out what exactly is going on. You take a more sort of comprehensive view. It's information, it's not data, if you understand that distinction. On the other side of this, on the consumption side, we have this quote from our friends at Gartner. Threat intelligence is evidence-based knowledge, including context mechanisms, indicators, implications, and actionable advice about an existing or emerging menace or hazard. So they're looking at threat intelligence from the consumption side, right? What I get from those analysts that CrowdStrike was talking about is information that I can act on as a defender, right? As a blue teamer, my job is to take this information and turn it into alerts and turn it into defense. I would love to talk more about this Gartner quote, but this is a talk on free tools, and if I wanted to read more of it, they wanted $200. So I'm going to go ahead and just move to the next slide. Where do we get threat intelligence from, right? I'm assuming that not everybody here is working for a Fortune 200 shop that has its own threat intelligence team, combing the dark web looking for stuff. So what do we as normal defenders take advantage of to get this threat intelligence? Well, there are a lot of vendors out there that are producing very good threat intel. I'm sure you're all familiar with the Verizon data breach report. A lot of really good stuff in there about attacker methods and methodology. Groups like Microsoft, their Mystic group internally produces a lot of really good stuff. Huntress, CrowdStrike. A lot of these larger security vendors will produce papers that are excellent and are full of very good information and very good threat intelligence that may be applicable to your environment. Google, especially since they acquired Mandiant, also puts out a lot of really, really good stuff. Very granular reporting with things like detection rules in it. It's fantastic. If you're just starting out, a lot of people don't realize this, but the MITRE ATT&CK site actually has a tremendous amount of useful threat intelligence on it. Now, since it's from MITRE, as you might expect, it's all sort of framed by the MITRE ATT&CK tactics list, right? So you can see for individual spots in their attack chain, information about adversaries, information about campaigns, information about threats. So if you are a representative from a manufacturing company or from a financials company, you can go to the MITRE ATT&CK threat dossiers and look through them for attackers who may be interested in your vertical or may be interested in your geographic region, and get very good threat intelligence about how these attackers are actually going to come after your organization. Remember, the name of the game here is we're looking for actionable intelligence about stuff that is more probable to affect your enterprise. Tragically, none of us have the time or the funding to secure everything against every possible threat, right? So what we want to do is find the stuff that we are more susceptible to, that the actors are more likely to use against us, and leverage that intelligence to secure our networks. Moving on from attack, ISACs are also an excellent source of threat intelligence. Given the current funding situation in the government, they may be more or less useful than they were when I made this slide. But ISACs, for those who have not been exposed to them, are information sharing and analysis centers. They're a public-private partnership. They're generally affiliated with a particular industry vertical. So there's the financial services ISAC, for example, for financial companies, or health ISAC, or there's a retail ISAC, there's the research and education ISAC. And these are groups of affiliated enterprises or affiliated institutions that share information about threats. So the financial services ISAC is, as you might expect, a fantastic source of threat intelligence about actors targeting the financial sector. So if you're in insurance or banking, that is a great resource to get into. If you are in one of these industries that has an ISAC and your particular employer is not a member of it, you should look into what's required, because it is a great resource. A lot of times they will have not just good threat intelligence reporting, but they'll actually have automated processes in place for sharing this information as it's distributed to all of its members. Stepping down a bit from ISACs, it's also possible that other institutions that your employer is affiliated with may have threat sharing agreements in place. I previously worked for a Blue Cross provider, and we had an internal sort of sharing mechanism among other Blue Cross providers. So whether you were Anthem, which is 30-some states, or Blue Cross of Vermont, which I think is 6 guys, and they also sell ice cream, they all shared threat intelligence with one another because we were all dealing with the same adversaries. Finally, there are community threat exchanges. So this screenshot is from the former Alien Vault OTX, Open Threat Exchange. I apologize, I don't remember what it's called now. If you go to the old site, you get forwarded. But people will publish threat intelligence that they discover on these open exchanges. So people who run honeypots, for example, will digest down the logs from those honeypots, again, turning it from data into intelligence, and share it on these exchanges so you can see what attacker techniques are being used, what tools are being used, what sort of traffic signatures you can look for if you want to alert on this stuff in the future. And finally, the most effective way to get threat intelligence for your organization is to generate threat intelligence from the logs in your organization. If you haven't seen this before, this is from a threat hunting framework called Peak. It's published by Splunk. The head of the project is Dave Bianco, who we'll talk about again in a moment. But as you can see, as you go through this threat hunting framework, in the third phase, the third column there, one of the steps is creating detections, right? Taking the intelligence that you have gathered, turning it into detections and deploying it to the rest of your infrastructure. If you have intelligence internally, that is gold. Why? Because obviously attackers are using it against environments just like yours, because they're using it against yours. So take the stuff that you learn from your threat hunts and your investigations, turn that into detection so you can spot that behavior in the future. Now, one thing that I want to mention is not all indicators are created equal. Has anyone seen this diagram before? Does this look familiar? Okay, a couple hands. So this is the pyramid of pain. This was published by the same guy as the Peak framework, Dave Bianco, about 10, 12 years ago now. It's of great historical relevance because it is the only useful thing that has ever been done in Microsoft Office word art. Now, the architecture is pretty simple. Obviously, it's a pyramid, hence the name. At the base, we have things that are trivial or easy for a threat actor to change between campaigns, right? And at the top, we have stuff that is difficult for them to change between campaigns. What we're doing here is we're sorting indicators of compromise by how likely they are to be a long-lived, useful indicator for us. If we write detection rules based around something like a hash value, that is transient. That is very easily changed in between campaigns by the actor because they're hash values. You change one byte or one little thing in the file, you recompile it, you change a comment in your malware, and it's completely different. The hash value becomes useless as a means of spotting things. That's not to say that these indicators at the bottom are bad or need to be discarded, but we need to keep in mind that they're not going to be very long-lived. So if we want to write rules around things like hash values or IP addresses, we need to be able to ingest that intelligence, turn it into rules very quickly, because they're only going to be good for 48 hours, maybe a week. Moving up the chain, we see domain names. I'm old. I remember like 6 top-level domains. Now everybody has a registrar and everybody has a .zip or whatever. So domain names are pretty easy for the attackers to change up. Network and host artifacts, those are getting a little more difficult for them to change, right? If they're using a tool that produces a particular traffic signature or writes a particular file type, that's going to be a little bit tougher. Tools are going to be really hard for an attacker to change up in between campaigns. And finally, true TTPs, right? If we can lock onto their procedures, their processes, their techniques, and write some rules around that, those are going to be both very high fidelity and also very long lasting. We have to remember that these adversary groups are like any other IT organization, right? They have a bunch of lower level engineers and interns who do not want to be retrained, who may only know how to use one tool. So if a ransomware group says, hey, I know we've been using this pirated copy of Cobalt Strike for everything for years, but starting tomorrow everyone's using Sliver, they're not going to be able to do it, right? It's going to take a massive retraining effort. It's going to be a big lift for them to change that stuff. So by targeting the stuff up near the top of the pyramid of pain, by targeting the stuff that the adversary is unlikely to change because it's going to require a lot of effort, we're able to write rules that will last for longer and be useful for longer. Okay? So with that said, how do we take this threat intelligence? How do we take these indicators of compromise? How do we take this information about what the adversaries are going to do and leverage it in our environment, get some actual information and alerting around that stuff? So the tool that I'm going to talk about, because it's the tool that I use professionally, is Security Onion. Security Onion, and this is a blurb from our website. Security Onion is a free and open platform built by defenders for defenders, and that is absolutely true. I always tell people that our secret sauce is all of our developers are former blue teamers, so we're building the tools that we wanted to have when we were doing this stuff. I worked as a blue teamer for about 15 years before I joined the team at Security Onion, and that's a pretty common story. All of us came from that side of the fence. It includes network visibility, host visibility, intrusion detection honeypots, log management, and case management, and then a bunch of other stuff. So basically, what this allows us to do is monitor our network traffic, our endpoint activities, and the logs that we're collecting, and match that collected information up against these high-fidelity IOCs and threat indicators that we're getting from the threat intelligence side. So we can leverage the threat intelligence to write rules in Security Onion that will then alert when we see this stuff. If we highlight what's most useful here, we'll see network visibility, obviously, host visibility, and log management. Those are the three use cases that have the most relevance for this detection engineering piece. On the network visibility side, we have three different layers that are captured by Security Onion. Basically, you connect your Security Onion sensor or standalone if you're running everything on one box to a tap or a span port in your network environment, maybe a packet broker if you're fancy and if you've got a lot of stuff going on. The network traffic is then viewed by a promiscuous mode monitoring port, and it's run through a few different stages of evaluation. There's an IDS engine, which is powered by Suricata. That is signature-based IDS. We ship with the emerging threats open rule set by default. You can run ET Pro if you want or some other rule set. But what that does is every network flow that goes by your sensor is then evaluated against tens of thousands of rules. And if a match comes up, then it writes an alert, right? So this is a detection opportunity for us. We can write a Suricata rule, and if it shows up in live network traffic, we can raise an alert about it. We do metadata generation and logging. By default, this is done with Zeek. Zeek was formerly known as Bro. If you've been around for a while, you probably know it by that name as well. What this does is it logs information about each network flow. At the very least, you're going to get a connection record. Connection record is kind of like NetFlow. You know, this IP on this port, talk to this IP on this port, and this is how many bytes they exchanged. If it's a well-known protocol, if it's something like HTTP or SMB or DNS, it will record additional metadata about that connection. So an HTTP record, for example, will write that connection log, and it will also write an HTTP log and say, okay, connected to this virtual host, this was the user agent, this was the status code from the HTTP server, information like that about the HTTP connection. And finally, there can be additional metadata depending on what happens. So if you download a file from an HTTP server, you'll get that connection record, the HTTP record, and also a file record with things like the hash of the file in it, right? So this gives us a lot of visibility into our network flows, and it's helpful because it allows us to aggregate this data very easily. We can do things like look for particular user agents, look for particular HTTP status codes, right? If we have a large network and we're analyzing the traffic with Zeek, we can query things like, hey, how about you show me all of the unencrypted RDP connections with Russian keyboards? That's all there in the network traffic, right? Why not look for it? Why not look for that threat? Finally, by default, Zeek is configured to do file carving. So if you have PDF files, doc files, EXEs, I think that's it by default, but you can set it for any MIME type. It will carve a copy of any file being transmitted in plain text and hand it off to Strelka for analysis. Strelka is a Yara rules engine. It's written by our friends at Target that we've integrated into the platform. So if you need to do static analysis of files as part of your detection engineering, that's all included as well. On the host visibility side, we collect endpoint logs and telemetry using the Elastic Agent. The Elastic Agent can be installed on Windows endpoints, OS 10 endpoints, or Mac OS, whatever I'm supposed to call it now. Running ARM or Intel hardware, those are both supported, or Linux endpoints. So as an example, for the Windows endpoints, we collect all of the normal logs, application, security, system, all that stuff. We collect extended logs for things like PowerShell, Windows Defender, Sysmon, if you have that deployed in your environment. We also collect forwarded logs. So if you're using Windows Event Forwarding, is anyone using that in their environment? Okay. Does everyone know what Windows Event Forwarding is? It's something awesome built into Windows that for some reason Microsoft never talks about. So we can ingest all that as well. We also generate endpoint telemetry data. So anytime an endpoint opens a network connection, makes a DNS query, writes a registry key, deletes a file, that stuff is all recorded as well, and that all gets shipped in. So if we have threat intelligence based around any of those use cases, we're able to write rules around it. And finally, log management. So if you have network equipment, I imagine most of us do, something like Palo Alto, Fortinet, Cisco, or if you're using cloud services, AWS, Okta, any of that stuff, those logs are all also ingestible via Security Onion. You can either send them in via syslog if it's something on-prem, or if it's something in the cloud that requires an API key, you can do a log pull periodically. And that stuff will all go through a pre-configured ingestion pipeline, all be normalized into the same database schema and put in one place. So we were able to ingest all of this stuff. How do we write rules to take advantage of it using the threat intelligence that we have on hand? We have a few different detection languages that are supported, and these are all, with the exception of Zeek Intel, which I'll talk about in a moment, these are all concentrated in a single module in the web interface. So all of your rule writing and tuning and application is all done through a web GUI in Security Onion. Zeek Intel is sort of an outlier. Zeek Intel is really for those bottom of the pyramid things. So if you're looking for a particular domain or a particular file hash or a particular IP address, you can write a Zeek Intel rule, and as Zeek is processing your live network data, if it sees one of these artifacts that you've specified, it will go ahead and generate an alert. Suricata, as I mentioned, Suricata rules allow us to evaluate live network traffic. This can be something as simple as if you see any traffic from my home net to this destination IP, raise an alert. Or it can be more complex, this C2 always has this particular phrase at byte 10 in the payload. In either case, you're able to write these rules and it runs them against the live network traffic as it's being collected by your Security Onion sensor. Yara rules are used by that Strelka component for doing static file analysis. I don't know how many of you have written rules in Yara. It's basically a very capable but still syntactically pretty simple string matching platform, right? If the file has this particular string in it, or if this string exists at this particular location, go ahead and raise an alert. If it doesn't, do not. If you're interested in Yara, you haven't played around with it yet. There was a talk a couple years ago by Paul Melson, who's at I think he's at Capital One now, at B-Sides Augusta, about writing good Yara rules. That is fantastic. I go back to it every so often as a refresher. And the most powerful one is Sigma rules. Has anyone worked with the Sigma project at all? Okay, a couple people. So the idea behind Sigma was somebody said, you know what, there's all of these rule languages for writing detections and queries. We should really invent another one. And it's a vendor and platform agnostic sort of detection meta language, if that makes sense. It uses a YAML syntax to write detection rules, and then you take that YAML rule and feed it through a Sigma compiler for your particular detection platform. So for example, we base everything on Elasticsearch. The querying is all done using Elastic Query Language. So if you take a Sigma rule and put it into our environment, it will turn it into an EQL rule. Sigma can also be compiled for things like QRadar or ArcSight or Splunk, right? Whatever you're using as a query language in your environment, Sigma most likely has a compiler for it. The cool thing about this is, one, when there's a new threat, somebody can just write a detection rule in Sigma and then everyone can use it. It's not like in the old days when you're like, oh no, I need to write a rule for this new threat, but I use QRadar and nobody's written a QRadar rule yet, so I have to write that. Not only do you not have to write it, but you'll know that you're actually detecting the same thing as everyone else, right? There's not going to be some subtle syntax problem where you're not going to see the stuff that's in the intel that everybody else is seeing because they're using a slightly different rule. What the rules are actually applied to, because we're turning them into queries, is all of those logs that we're collecting. Now, I know that sounds like a really simple, obvious concept, but think about it for a second. This means that every log you're collecting in your environment, and if we go back here, we're collecting a lot of different kinds of logs. Every log that you're collecting can now be used as a detection opportunity. Any piece of metadata that Zeek is generating about network connections, any process running on an endpoint, any registry key, anything that you're able to import into Security Onion, which is pretty much anything, can now kick off an alert if it matches a piece of threat intelligence. So if you get something that says, you know, an executable with this name running from a user's downloads directory is probably bad news, you can write a rule for that. If you have a network blacklist, you can write a rule for that. But if you can generalize it to something higher on the pyramid, which is what we're going to do in a moment, you can write rules for that too. It's very simple, but a very powerful concept. So what does our detection engineering workflow look like? Well, we need to take our threat intelligence, and the first thing we need to do is choose our indicator, right? We want to take that threat intel and pick something about it that is high enough on the pyramid that we can write an alerting rule that will have longevity, will have a minimum of false positives, and will be a reliable indicator of that malicious activity. Once we've figured out what our indicator is, we need to identify where we're going to find it, right? What's our data source? Is it going to be in live network traffic? If it is, we should probably write a suricata rule. Is it going to be in an endpoint or a cloud log? That would be a Sigma rule. Is it going to be in a static file somewhere? That would be a Yara rule, right? We need to figure out exactly how we're going to see this malicious indicator, this malicious data, so that we can write the alert about it. Then we need to write and test the detection. We need to deploy to production, and we need to monitor and tune it, because inevitably there's going to be some weird thing that trips the rule that you don't expect it to. Like anything else in security, this obeys the laws of thermodynamics, right? You can't win, you can't get ahead, and you're not even allowed to quit. It's an iterative process where you're continually refining these rules, squeezing out the false positives and making sure they work as you expect. All right. So before we get on to an example, does anyone have any questions at this point? All right. If anything comes up, we'll have some time at the end too. All right, so a workflow example. This actually comes out of one of our training sessions, one of our training scenarios, but I thought it was useful for this, for illustrating kind of how you pick out a good item from threat intelligence and write some rules around it. So a recent threat hunt, we're doing the going back and eating our dog food peak threat hunting chart here. A recent threat hunt has identified data being exfiltrated from a workstation by a malicious process named wombat.exe, because I thought that was a funny word. This executable had an original file name of dnsexfiltrator.exe and was apparently sourced from GitHub. And this is true. If you go to GitHub and search for DNS exfiltrator, you'll get the malware that I use in this training scenario. It was written to disk by another executable called avupdate.exe, which was downloaded from a counterfeit website that the user was sent to by a phishing email. Wombat.exe was exfiltrating files using encoded DNS subdomains on very long TXT queries, all for the domain 3scoops.online, because .online domains were free. We have the email address that sent the phishing email. We have the hash values for avupdate.exe and wombat.exe. We have the IP addresses of the counterfeit website, the C2 for AV update, and the destination of the DNS requests. So we have all of this threat intelligence, right? This is all stuff that we found during a threat hunt. We're doing our post-mortem, we're writing detections around it. Now we need to decide, how do we take this threat intelligence and winnow it down into a detection rule that'll be useful for our environment? All right, so you are here. The first thing we need to do is take a look at all this intelligence and choose our indicator. So I've highlighted the stuff that might be useful as a source for writing a rule. We've got executable names. We've got wombat.exe. We've got dnsexfiltrator.exe. We've got avupdate.exe. We have the technique that they're using to encode DNS subdomains. We have the top-level domain that they're using, 3scoops.online. We also have the email address that sent the phishing. We have some IP addresses. We have the hash values for the various executables. So how do we detect this in the future? Well, let's refer to our pyramid of pain. We've got hash values. We've got IP addresses. We've got domain names. Those are all good indicators. And they're probably more helpful if we're doing a retro hunt than if we're hunting things in the future, because those are all very easy for our threat actor to change. You can just recompile something to get rid of the hash values, or you can sign another contract with DigitalOcean, it's always DigitalOcean, to change IP addresses, right? Or he could register a new free .museum domain or whatever. So those indicators are not going to be super useful for us just because they're not going to last a long time. Thinking about the threat intelligence that we have, probably the best thing that we've got is that technique, right? TTPs are right at the very top of our pyramid here, and the technique of encoding DNS subdomains in log TXT queries, that looks like it might be a winner. TXT queries are not super common, right, in most environments. So just seeing those is going to be a little bit unusual, but you may have some in your environment. But the combination of very long DNS subdomains and TXT records, that's going to be a good high-fidelity detection for us. And the best thing is, again, it's at the top of the pyramid. This is not something that's going to be easy for the actor to change. If they want to change the name of the executable, they just have to recompile it with a new name. If they want to change the hash value, they just have to change a comment, and they're done. If they want to change the IP address, that's easy too. But changing the actual TTP, the method that they're using, is going to require upheaval to their whole infrastructure, right? On the outside, they've got some DNS server that's receiving and decoding this traffic. They'll have to tear all that down. If they want to change the tool substantially, even if they rewrite it in, Rust or Go or whatever the cool malware devs are using these days, if they're using that same technique, if we write a rule to catch the TTP, we're still going to be able to catch it. Right? So that's our goal. We want to write something that is going to be high fidelity and also long lasting. So if that is what we're going to try to alert on, what's our next step? Well, we need to identify the data source. DNS queries are pretty common artifacts in an enterprise environment, right? There's a lot of places where we can eavesdrop on our clients and see what DNS queries they're making. So we have a bunch of potential sources here. We could use the DNS metadata that's being generated by Zeek, right? As I mentioned, every network flow gets a record written, a connection at the very least. If it's a well-known protocol like DNS, it'll get a DNS record written as well. We can look at the DNS queries in our endpoint telemetry, either the Elastic Agent stuff that we're collecting via Security Onion, or if you're using some other endpoint agent, CrowdStrike or Carbon Black, Defender, something like that, it probably logs DNS queries, so we could check that telemetry as well. We could check logs from our internal DNS server. Microsoft finally realized in the year of our Lord 2016 that maybe that would be worth logging, so you could log it on your domain controller if that's what you're using. Or if you're using some other DNS server, that's another thing you could ingest. Or you could write a custom Suricata IDS signature, right? If I see a DNS flow and it's looking over this length and it's a TXT file, go ahead and write an alert. So, who has an idea of which one of these we should go with first? Somebody close, because I can't throw that far. Anybody have a guess?
First one.
What's that?
Top one.
The top one, the DNS metadata from Zeek? All right. So that is also my inclination. The reason being, the DNS metadata from Zeek will be captured independent of the client's configuration, right? If we have DNS queries in the endpoint telemetry, that's good. We can capture that. It's helpful. But if you ask your procurement department and the person who runs your EDR platform how many computers you have, are they going to say the same number? They are not, right? You've got stuff in your environment that is missing EDR, that does not have endpoint telemetry. So it's possible that if you're relying on that to capture this stuff, you may miss some. Same with logs from the internal DNS server. Environments are getting better and better about this, but how many of you block queries to outside DNS at your firewall, right, as a matter of egress filtering? Some people do, a lot do not, right? Sometimes people will leave that open because, hey, who knows how stuff on the guest wireless is configured or whatever. So it's possible that you'll have these outside DNS queries happening and you're not aware of them, you don't see them. A custom Suricata IDS rule would also function for the same reason as the Zeek metadata, but then you're putting additional load on your Suricata sensor, so if you can just do it with the log analysis, that's probably a little bit less overhead, but either of those would work. If you really want, you could also write multiple rules looking for the same thing in multiple data sources, right? If it's something very high criticality that you want to make sure you don't miss, you want to cover every edge case, that's always an option as well. All right, so we figured out what we're looking for. We figured out where we're going to look for it. How do we write and test the detection? So this is the detections interface in Security Onion. I apologize, I know it's a little bit of an eye chart at this distance, but all I wanted to draw your attention to is the detection logic down there at the bottom. That's what a Sigma rule looks like. It's a very basic key value YAML sort of syntax. You basically just write out what you're looking for. In this case, we say, okay, we're looking for DNS records from Zeek. That's what the log source piece is. And if the query is a type TXT and it is a length greater than 100, then go ahead and raise an alert, right? So the syntax is very simple. It's, as you can see, there's two selection clauses there. And at the bottom it says, if all of these are true, then the rule as a whole is true, go ahead and raise an alert, right? What's going to happen when we put this into production? It's going to take this Sigma rule, it's going to compile it into an EQL query, an Elastic query, and that query will be run against the collected logs in the Elasticsearch database every 3 minutes. And if there's a match, it's going to raise an alert, right? Again, very, very deceptively simple concept, but what we're doing here is we're turning everything that we log into something that we can write a detection and alerting rule around. Very, very powerful. All right, and then the next step, obviously we deploy to production, we compile this into an EQL query, we activate it, it will start running against that backend database, running that query automatically, and then finally we need to monitor and tune. This is when we find out that the proprietary control software for the printers in your main office all make very long text queries every single day, and so this alert is going nuts. So there's going to be a tuning process, right? You have to go through, you have to figure out, okay, this traffic needs to be excluded. If it has this characteristic, it needs to be filtered out, et cetera. That's all done through that same detections interface. You can take other characteristics of a log and tell it, don't raise an alert if it matches these ones, but otherwise raise an alert if it's a long DNS text query, okay? Another possible scenario, I copied this from one of Google's documents a while back. Threat bulletin outlines the behavior of a group using scheduled task XML triggers as a persistence mechanism. So a lot of threat actors do this. They'll put in scheduled tasks on a Windows endpoint to refresh the malware that's cached on there or to establish some sort of persistence or backdoor. So what characteristics can we look for? Well, we've got scheduled task XML files, we've got Windows services, we've got scheduled tasks, right? We have a lot of these sort of lower level items, and depending on your environment, you may be able to alert on one of those, right? If you look back in your endpoint logs and nobody is running that scheduled tasks.exe command line tool, then go ahead and just write an alert for that. Because if somebody suddenly starts using that, either they downloaded a script and ran it without checking it, which I know none of us as security professionals have ever done, or something nefarious may be going on. If you need to get more fine-grained about it, then you can look at the TTP of it, which is it's opening a P-link, which is part of the PuTTY project, backdoor for SSH connections. So do the Windows servers in your environment generally have SSH open for connection? Maybe they do, maybe they don't. I mean, it's your environment. I wouldn't know. But generally speaking, in the places where I've worked, people tend to favor RDP or other kind of old school Windows stuff as opposed to automating things with SSH. Maybe it could be as simple as, you know what, if I see SSH traffic successfully connecting to a Windows host on my network, that's weird enough. That's enough of a reason to raise an alert, right? That's enough out of my normal operational baseline. And then you go through the same process. You choose your indicator, figure out your data source, write and test the detection, and then put it into production. So in conclusion, what we want to do is take good, solid, actionable threat intelligence and turn it into alerting rules in our environments. And we want those indicators, we want those pieces of intelligence to be high enough on that pyramid of pain that once we put it into production, we're not going to have to remove it or lose its efficacy right away. We want something that's going to have longevity and something that's going to produce a minimum of false positives. So if you use this sort of detection engineering workflow to pick out your indicator and then put it out into your environment, I think you'll have a lot of success with that. All right, here is my contact stuff. So if you have any questions, the slides are posted on my GitHub. I think they'll also be posted on the RSS website, so you can download them from there if you want. If you want to follow me on Blue Sky, if you want to send me emails, feel free. All right, so that's all I've got, and I think we have about 6 minutes left. So does anyone have any questions? David.
You are going to get CTI items from your sources all the time. Mm-hmm. Some of them, based on where they are in the pyramid, are going to become obsolete faster than others. Do you have any sense of, other than manually just looking at them day to day, how to manage that flow, how to get new stuff in and prioritize it, and how to flush out old stuff so you don't end up with 32,000 rules?
Yeah, so the question is, basically how do we keep things fresh and active, right? As I said, the stuff at the bottom of the pyramid, and you can get your pyramid, you can get your onion after. The stuff at the bottom of the pyramid is not useless, but it does turn over faster. So the key to using indicators like IP addresses, domain names, hash values, is to automate the ingestion process and the deployment process into your environment as much as you can. When I was at Blue Cross, we got a spreadsheet of suspicious IP addresses once a week from one of our intelligence sources, right? So what we would do is we would take the IP addresses in there and programmatically dump them into a MISP instance. MISP is a threat intelligence platform. It's another open source project. MISP has the capability to automatically generate Zeek, Intel, or Suricata rules. So we were able to automate the whole process from the time we got the spreadsheet to the time those rules were on our sensors looking for those IOCs was a matter of minutes, right? Because we could just automate the whole thing with API calls. So if you do have a lot of those indicators, you want to automate getting them into action as quickly as possible, so that you can maximize their shelf life, short as it might be. Any other questions? Yes, Jonathan.
Yeah, so how do you balance, how do you balance the storage that the system manages to not store everything historically, but still have enough data to detect like APTs that might be in your system? Like, storage is expensive. Nobody wants to keep 3 years of failed login data.
Yeah, absolutely. So speaking just for Security Onion, because obviously it's going to vary depending on the platform, but we're built on top of Elasticsearch, so everything is clustered, and we do have explicit lifecycle management stuff. So you can write your hot data to the more expensive solid-state storage, and then age it out to the spinny disks in the decommissioned vCenter server you've got kicking around somewhere. And ultimately snapshot it up to something like S3 if you want to hang on to it for a longer period of time. Different data sources can have different life cycles, so you can retain your Zeek metadata for a long time, but turn over your endpoint logs after 60 days if you don't find them useful anymore, right? And again, it's going to depend on your threat model and your tolerance, but you can scale out horizontally pretty well and pretty inexpensively by just throwing more local disk at the problem. I always tell our customers, we recommend local disk for a couple of reasons. One, it's faster. It's just more performant than trying to put everything on a SAN and access it across shared media. And two, if you need to add 20 terabytes of storage, you can do that at Best Buy with your corporate card, or you could ask your storage admin and he'll come outside and key your car. All right. Any other questions?
You mentioned that Sigma rules can be very easily shared, no matter what platform is being used. Is there a good place where that information is being shared, or good threat intel platforms to ingest that data from?
Yeah, so there's a really good Sigma repository that's maintained by the Sigma project itself. I think it's just sigmahq.io. And they have several sets of rules. They have some core rules which are very well tested, and those are the ones that we bundle by default. And then they have some more esoteric ones for particular operating system logs and that sort of thing. So if you're in a Mac-heavy environment, they have Apple endpoint alerting rules written in Sigma that you can integrate. But even if you're not using Security Onion or you're not using anything Elasticsearch based, as I said, the point of Sigma is the detections are all platform agnostic. So take a look at it and see if those rules are useful with whatever platform you're using now.